Hello guys and welcome to the final episode in the I-Beam Trolley mini-series, and it's a big one today. It is the assembly, and without further ado, let's jump in. So we will be starting a new assembly, and the first part that we will be adding is the carrier, not the I-Beam. Right, we will make a subassembly, and we will make a subassembly of each of the two carriers, and then we'll bring it together in the main assembly with the spacer shaft, nuts, and spacers. So, starting tip right off the bat: when we're putting a new part in, we don't just click randomly. If it's the very first part, it's a good idea to click on the origin. You see that I'm getting that little icon next to my pointer. That means that I'm clicking on the origin. And what happens if you do that is we have aligned the coordination system of the carrier part with that of the assembly. And then the next thing you do is you anchor the part. And then we insert the I-Beam roller shaft. 1, 2. We need 2 of them. Okay. Now, we said that we'd be putting these in these holes and then welding them. So I will just select that outer circular edge. Select this one. I didn't anchor it. And then hit Control Q. Now, what happens here? We get the assembly constraints menu, and it's pre-filled. It knows I want the fastener constraint, which is a constraint that is like a coaxial and a coincident constraint at the same time, right? Of course, now it's the other way around, so I will click the flip button, and now it's the way I want it. So this part now can rotate, but it cannot go in and out. And sure enough, if I open its reference planes, you can see that it can rotate, but it cannot go in and out. Now, if I want to fully constrain it, I will just create a parallel constraint between these two planes. Again, I selected the planes first and then open the assembly constraints. Hit 0, now they're parallel, and hit OK. Let me hide the reference geometry. Now you saw that as soon as I hit OK, the assembly constraints dialog box went away, right? And that is because I had selected geometry before I opened it. Now if I hit Control Q and I open it and it's empty, look what happens. I click here, I go to select my geometry, I select this edge and this edge. No, I don't want the angle constraint, which was the last one I used. I want the fastener constraint, and I want to flip it. Okay. Look, now it didn't go away, right? So I'll just show the reference geometry. Go back here. Select this and this angle. Control A is 0 degrees of angle. And OK. And now you saw that I had to close that assembly menu, and the only difference is that I opened it without having geometry pre-selected. That's a little detail there that can help you, depending on what you do, it can help you save a bit of time. Okay, so I've put these shafts in. Of course, these will be welded, right? Okay, so what do I do now? Now, it's a good idea to put the roller bearings in. Basically, we kind of assemble it as we would in real life. That's the way I like to do it. It makes more sense to me, and it's easier to keep track of what happens. So the roller bearings we got from SKF, right? It was a 3200. The double angular contact double roll ball bearing. So you go to rolling bearings, ball bearings, angular contact ball bearings, double angular contact ball bearings, and we will find it here. It's the smallest one of the series, so I can just click here. I don't need to search it like I did the other day. Go to the CAD tab, and there you go. We can select it now. It's got a lot of different formats, but it doesn't have a Libre, so we will go with step. Now, a quick tip here: if for whatever reason, right, you download something and it doesn't show up correctly when you download the step file, go for the SolidWorks version, right? You can go for the Creo version as well, or you can go for the Inventor version as well. Why is that? Because a Libre opens those formats as well, and they're more likely to be correct because they're not an export, right? They're native files. I will make an example of that. I will show that as an example later on from the McMaster car website, because this is a large part. I don't want to waste time on the conversion. Our zip file could not be generated, yet I see the zip file and it's got the step file in it. So okay, I will just cut it and paste it on my downloads folder and then close the folder out. Then I go into my assembly. That's how we showed that we're inserting step files in a previous video. I just put the step file in my downloads folder. I don't really care where it is because Libre is going to create an Libre part for it. And as soon as I create that part and then save it to the location I want, I can delete the original step file without any, let's say, consequences to my assembly. Okay, so import file options. You see that this is a conversion menu. I hit OK, standard, options, and it's telling me that the file was imported without errors. Okay, and in a Libre, you can just click and drag, control click and drag to create a duplicate of an assembly, and it will understand that you're looking for the entire assembly, not just a single part. So now I will again constrain this with a fastener constraint. Yep, that's where I want it to go. And nope, I want this the other way. There you go. I am done. Okay, now to fully, constrain these, to fully have them stay on these shafts, what do I want? I want the circlips. Okay, let's go to McMaster car for that. And I want the circlips. Well, I want an external. First of all, I need it to be metric. Then I want external. Then I want the ring OD. Is it ring OD? No, I want the shaft OD. Oh, for OD 10 anyway. Okay, again, it's showing me the groove dimensions, which were very useful, when I was designing the groove. Now, look, default download format in McMaster car is 3D step, right? Let's say I want to do 3D SolidWorks, okay? So I've downloaded the SolidWorks part, and the way you handle that, right, is you open the folder that you downloaded in, and then you, you close everything off, and then you go to File, Open, right? And you open it from there, you get the same actual menu, and now it's imported. Standard issue with Libre, you bring in a part, an imported part, and it doesn't show anything, right? But if you regenerate all, you will see the part, and if you change the color, you will also see the part. That's been an issue since V24, at least that I'm with Libre. But like Shift F5, it's good to go. I'm not sweating it. And then again, look, this tells me it's an imported SolidWorks file. Okay, quick tip there. McMaster car parts come with this file name that starts with its product code. Well, and that's not very helpful. So this is a DIN 471 external circlip. So what I like to do, I will do it as a save as now, but ideally you should have done it in the save phase of this whole thing. So you just go DIN 471 right? 10 millimeter external circle, right? So you save that, but in any case, let's bring it in. So we can delete this and insert this. Again, I want 2 of these. And again, I will do the fastener constraint. Okay. On. Again, we are away and we're done. This can still rotate if you really want to pin everything down. You can, but just giving a random parallel constraint, or just even that would work. So let's not overthink stuff. Right. And now, right, if I was assembling this on my bench, what would be the next part? The next part would be the roller. And I didn't assemble it. Look, okay, everybody makes mistakes. If I was assembling this on my bench, I would put the bedding in the roller first. But anyway, let's bring the roller in now. And the reason I would do it like that is because the way I designed it, it's a lot harder to get that circlip in now. But okay, we're not worried about that. In real life, I would really need to put the bedding in the roller first, put that circlip in first, and then put it on the shaft. But okay, let's do that circlip. 30 millimeters. Let's go back to McMaster car. This time we need an internal circlip. Right, so we will go for the internal retaining rings. We want metric. We want 30 millimeters. DIN 472. So 471 external, DIN 472 the internal one. And let me just do the step file now. Again, I can just minimize, come in here, downloads, that. I'm okay now. Okay. File import without errors. Let's put it in there. Let's get a duplicate and let's do the same thing we did before. Is that the way I wanted it? That works. That works for me. Okay. Okay. Same thing here. And again, I need this split. Okay, and now I need to assemble these rollers. So again, fastener constraint. I mean, you see that basically it says fastener constraint, but it has so many different uses, right? Just remember that it does two things at once. It does coaxial and coincident, but it doesn't constrain the revolution, right? And let's see here. There you go. There's our gap, right? That we accounted for when we were making our shaft. Everything is done. So this is a complete carrier assembly right now. Okay. And I'm going to save this, and I'm going to call it the carrier subassembly. Okay. Oh, well, I mean, it's trying to save it in the downloads folder. I'm going to change that. But before I change that, again, McMaster car part. No, this is a DIN 472 13 millimeter internal circle. Okay, now I'm going to select my folder. Hit OK, and everything is saved. Okay, now every step file is now converted. Everything is working perfectly. Okay, so now I can start the main assembly. The way we do that is we start another assembly. And the first part we bring in is the actual I-Beam. Okay, we click on the origin, finish, then right click on the part and anchor it. You see here it says anchored. Okay, now we're going to bring in our subassembly, carrier subassembly. Okay, we have a complete carrier here. Okay, and how are we going to assemble this? Now, you will see that there is going to be some fine tuning in the assembly later on to get everything to line up correctly and whatnot. And that has to do with the number of spacers, right? The number of spacers I went with in the shaft was a guess, right? So the way we would assemble this is this. First of all, I'm going to bring up this triad and kind of, bring it in the orientation that I want it to have. Okay, so sort of like here. And then I'll also bring it near the position I want it to have. I mean, that's just avoiding some extra unnecessary work down the line. So I selected these two surfaces and I want them tangent. And then I want this and this surface, and I also want it tangent. Okay. Then I want this flange here of the roller and this edge of the I-beam, I want them at a distance of 1/16 of an inch. See what I did? That works, man. That definitely works. Could have made the roller a bit larger actually, but I gave it a large fillet, so I could have made it a bit longer, but it should be fine. So I am fully assembled here. I'll create a duplicate. What I'll do is I will assemble the duplicate based on the other carrier because I want them to move together. What else? This accent as well, that should be fine. Okay, and now the distance. There you go. So this is starting to look like an I-Beam trolley already, right? And some exciting stuff. Okay, now I'll bring in the spacer shaft. And where is my spacer shaft? There's my spacer shaft. And I want that to be coaxial to this hole. I want it to be smack in the middle. So I will show its reference planes. And then just say that, sorry, this plane and this plane. I'm looking at the arrows to make sure I am selecting the correct plane, right? So these two planes are coincident, and yep, I should be good to go. Okay. Now, I want to fill this space in with spacers inside and outside, and then I'm going to put the two nuts in, and that's going to hold everything together. But we also need another part. That other part is the hook. Okay, so let's design a part inside the assembly. We will create this part inside the assembly. So I will go up here and just click part. And this will be the hook, right? And okay. You know what? I'll design it in here. Now, make sure that when you're selecting, when you're inside the assembly and you're making parts, make sure that when you are sketching on a plane, you select it from here, right? This is a top tip, not for a Libre, but for most other CAD systems. You'll see that a Libre already only shows the parts planes, but there are other software where you only see the assemblies planes. In any case, all parametric software, when you're designing new parts inside the assembly, make sure that when you sketch, you're sketching on the parts planes, not the assemblies planes. So having said that, I'll sketch on the YZ plane of my part. So the hook is just a sheet, a laser or plasma cut sheet metal piece. Right. So I want this to be 1 inch. I want this to have a thickness. I don't know. Yeah. Okay. Lines here. Okay. Vertical constraint there. Okay, we already have. Cool. Now let's trim this little piece off. And let's say that this hangs like, I don't know, 6 inches. 4 inches. 4 inches. And then I'll start a tangent arc. Come on. There you go. Again, a vertical constraint, and let's give that 1.5 inches. Okay, that didn't work. So in vertical. So I'll leave it here and give it a coincident, and then give it a tangent. Oh, doesn't need the tangent. Okay, so that's my hook. Let's do that 1 inch. Let's make this distance. Okay, which one do I want now? Oh, man. Okay. I just want these to be. Oops. I don't want these to be clocks. So I want this to be 1 inch. Okay. There you go. That was the mistake before. Yes, this makes more sense. I mean, in any case, let's suppose this is a hook. Okay. So I'm going to do the tie tab move and say that this is a 5 mil hook. And now that we're done with the design, okay, I will right click here. I will check edit part, and look what happens. I can move it freely. That's why I stressed that we need to design it on its own plane, right? Because if I was designing it in the assemblies plane and use the assemblies origin, then I wouldn't be able to move this. I would move it and it would regenerate back into its original location, which is annoying. So again, I'll make this coaxial. I'll also show its reference planes, and because I did the mid plane with the Titan, not the face, man. Then- Okay, so I realized that I had quite a few constraints that were unhappy. So let me try and do that again. Okay. Okay, I've got the angle going there. Here, let me give this angle as well. And then I suppose that now the simple coaxial should be fully there. Okay, so the reason I'm getting this X here, right, a Libre is not like SolidWorks. You don't get, yellow marks and red marks and all that. It's just telling you that there's an issue there. If I go check the status, there it's telling me that this is an overdefined constraint, right? So yes, it can solve that, but for some reason it thinks that that doesn't need to be there. And I'm going to do a video about that. So when you're selecting two faces in a Libre, it's not like SolidWorks or Fusion or whatever, where the software automatically thinks that you selected the plane that face defines. So here, by selecting these two planes, these two faces, I just selected these two faces. So, I mean, when I gave it an angle of 0, that means that this edge here with the other edge should be at an angle of 0, and also this edge with this edge should be at an angle of 0, which basically defines the stance of this thing in space completely, as well as the faces themselves. So that's what I think happened, and that's why it doesn't need the second angle. In any case, let's just go give that the offset of the roller flange again. And it's happy now. Okay, cool. We've still retained this coaxial, so I'll just do this and this. Yes, no. Okay, and then this and this. Okay, and then this and this. What? Offset of 0. Okay. It's not clear. It just clears, which is how we like it. Okay, so that hook is terrible. Luckily, we can fix it. I'll edit it in a separate window now. Again, Shift F5. I'll edit my sketch here. I think that if I take this at an angle, it'll make more sense. Like 12 degrees. Yeah, that looks more like it. That's almost acceptable. Okay. Now, and we also need to edit here. We need to give the hook a color. Okay, let's make it bright red. Bright red, easy to spot from far away. I could have made it bright yellow actually. Anyway, let me turn off the planes of the individual parts, also known as reference geometry. And this is our I-Beam trolley. All it's missing is the flange nuts and the spacers. So this looks like an I-Beam trolley. All it's missing are the spacers. Okay, now the spacers, I find that it's more trouble downloading than designing. I did design one in this in the video that I made the spacer, and I should have it already. So if I go in here, I should have a piece called a 1-inch washer. Now put it in here. Now I want 4 of these. Why 4? You'll see why, because I'll be assembling them and then patterning them. We need a fastener constraint there. We need a fastener constraint there. Don't want that going away now, so we need a fastener constraint there. Where are you? Fourth one? There you go. And we need another fastener constraint there, and like so. Let me just save that. Yes, I want to save the hook. Yes, I want to save it in the same folder. Quick tip here, I don't think Libre does internal parts like SolidWorks. And thank God for that. I kind of hate that in SolidWorks. In any case, so let's say I'm the designer, right? I'm the chief engineer of this project. Me and my team will design all of that, and I want to give it down to the guys on the production floor to start making this, or to the production engineer so that he can design his production. It's pretty important that I tell them how many washers they should put in the plastic bag, right? So how do we do that? Well, this is how thick was that? Okay, that's a different number in inches, but we can go with that. So that is 3.3528 millimeters. And the space from here to here that it needs to fill is 36. Let me write these down. So I'll just open it. This is 36.235003. That one was 3.32528. Okay, so if I divide these two, right, I get 36.3250. Well, divided by this point, this. The problem, I need 10 washers, and then I need 0.8 of a washer, right? And that doesn't work. That doesn't work because I can't put 0.8 of a washer there. I need to have an integer there. So why do I do that? Well, again, let me show this. So this will work with the calculator for a bit. So I have a 0.8, right? So 0.8 of this thickness is 2.6 millimeters, okay? 2.7, let's say now, a 1/16 of an inch is 1.5. So my gap here, right? My gap here is 1.5 roughly. And I need to find 2.6. So I can't move these things inward to get the number to become an integer. Of course, if I could, I would prefer it because I would be using less spacers. So I need to move it outward. I need to move it 0.2 times 3.3528, which is this number. Just copy this directly, right? I'll go into my equations, my equation editor. And look, these are the two offsets. These are the two 1/16 of an inch. And I will just say plus Control V mm plus Control V mm. Hit OK. Generate. These moved. Now let's do that again. Let's check this space. Okay, now the number just changed to 36.905563, and if I divide that, And that by 3.358, I get 11 and a James Bond. It's close enough, right? This is close enough. You can just say that this is tolerance, right? I'm completely happy with this. So now what I'm going to do, I'm going to take this and say, yeah, I'm going to linear pattern this along this direction, right? And I want 11 of these, and my spacing is 3.3528. Okay, and would you look at that? And of course, we can do the same thing here. Well, actually, you know what? I can just say that this is C1. And then I can just say that this is D12. And change direction. Okay, now when I tweak this pattern, this will correspond. I'll speed through the same deal on the left and right spacers. Just bear in mind that in this case, what we will be playing with in order to make it larger or smaller is the actual width of the spacer shaft. Right? This is not an assembly issue. This is assembled to be dead center. So we will be changing its width. Okay, guys, so it seems that the difference here is about 1/10 of a millimeter. I'm happy with that. I'm not changing the spacer shaft. Okay, so I will just make this 4. This was the 12. Yeah, wait. Go. Same here. Let's linear pattern this. I want this to be C7, like the Corvette. Was that the last actual Corvette? Yeah, C7 was the last front-engine Corvette. Right? So the last real Corvette. Yeah, there you go. Sorry for that, guys. Sorry for that C8 Corvette, guys. If it ain't got the engine in the front, it's not a Corvette. And now I need to add my 2 flange nuts. Okay, I have somewhere here. Yep, serrated flange lock nut. So all that goodness. Let's do 2 of them at the same time. This edge and this edge get a fastener constraint. Okay. And then I'll play with the offset until the serrations touch. 2.1. Say, nice, that's good. Let's go do the same thing here now. Offset 2.1. Reverse the offset. And okay, let me do one final little thing. Edit it here. Change the color. Give it a nice, oh, I don't know, pink. And look, guys, what we have here. What we've got here, guys, is an I-Beam Trolley. The things that you see are left behind and then, just catch up after a while are the patterned instances, right? You don't regenerate immediately. Hey, I can live with that. Okay, and that, guys, was an I-Beam Trolley, right? So how would you adjust this for a larger, um, how would you adjust this for a wider I-beam? Well, you take the lock nuts out, you take these 4 washers out, you take the carrier out, you add 2 washers on the inside, add the carriers, lock with the nuts, you're good to go for a wider I-beam, right? And that's it. So that was the I-Beam Trolley mini project series. We designed a product that has everything it needs to go into production and go on a shelf, right? We did that over a few videos with the Libre. This is a complete product. Everything you need to manufacture and assemble in order to create that product is there, and that can go like that on a product shelf. That was the purpose of this mini series. I find it amazing that it is so easy to do these days with so powerful CAD systems that we all have available to us. And I hope you liked it. And I hope I see you in the next mini project series. Spoiler alert, there are going to be gear ratios involved.